Higher section 3, example 1. The diagram shows the graph of a function y equals f of x. Copy the diagram and on it sketch graphs of y equals f of x minus 4, x minus 4 within the bracket that is, and part B is 2 plus f of x minus 4. So if I look at A, first of all, f of x minus 4. So x minus 4 in the bracket. Remember, in the bracket denotes horizontal movement and you go against the grain. So if you think about minus 4, it almost makes you think that you would move in the negative direction, i.e. to the left, but you actually go against the grain and you move in the positive direction. Now, basically what happens with this curve then is it just gets shifted 4 units to the right. Now, within that, if we think about it, if something's getting shifted horizontally, the y-coordinate doesn't change. What does change though is the x-coordinate, so I need to record these points where they end up now, Q and P. So Q will be moved 4 to the right, so minus 4 will end up on the y-axis with an x-coordinate of 0, and 1 will shift over to have an x-coordinate of 5. So it's about recording my new points and also drawing the new curve. And there we go. Part B is now looking for 2 plus f of x minus 4. Well, all I'm going to do now is use this blue curve that I've just found and shift it up 2 units. And there we go. So 5 moves up to 7. The x-coordinate of 0 doesn't change, so obviously that would need to be 0, 7. And here 5a becomes 5a plus 2, so you move a up by 2 units, and you would need to write that as an expression as a plus 2, and that's the final answer to the question. Section 3, question 2. The diagram shows a sketch of the function y equals f of x. Copy the diagram and on it sketch the graph of y equals f of 2x. So f of 2x, what that indicates is a horizontal compression by a factor of 2. So in essence what's happening is the thing's going to get squashed in by a factor of 2 horizontally. Now you need to think about what happens there is that affects the x-coordinates, but a horizontal compression wouldn't affect the y-coordinates, here 8, 0 and 8, but it would result in a compression of the x-coordinates minus 4 and 2. So there we go, that's a horizontal compression. Minus 4 gets compressed by a factor of 2 into minus 2, and 2 gets compressed by a factor of 2 into 1. There's no adjustment of the y-coordinates because the horizontal compression won't affect the height. 0, 0, well 0 compressed by a factor of 2 still gives me 0, so that still goes through the origin. Part B then says, on a separate diagram, sketch the graph of y equals 1 minus f of 2x. Now, to get going, the best way of thinking of that is actually minus f of 2x plus 1. It's a wee bit more intuitive as to what to do. So remember, for multiple transformations, what we need to do is think about BODMAS. Now, with BODMAS, what's going on is you need to do brackets first, then multiplication, then addition, subtraction. So we do this bit first, the horizontal compression. That's happened already. Then we would do the minus 1 times bit, and that's a reflection across the x-axis. Then we would shift the thing up by 1 unit. So first of all, there's f of 2x, and the second transformation is to reflect it, minus f of 2x, so that's then in effect the bit in the bracket. That's the reflection, the minus 1 times bit. Now what we need to do now is move this one up by 1 unit. And there we go, it's been moved up by 1 unit. Minus 8 up to minus 7, 0 up to 1, and minus 8 up to minus 7. And I've also denoted a vertical shift upwards in the curve. And that's the final answer.